It is an extension that's available with Civil 3D. It's a separate application. In this program, to set up, we're going to talk about a little bit of low pressure system design. And let me open up a model I have so you can sort of see what it will look like. Essentially, your controls at the top are what you'd use to add this, and it works very much like any other software that you've seen, to add storm sewer design or how HydroFlow works. You add a junction. A junction is a manhole. Just click the junction, click a location, and that's how you add a manhole. You can double click on it, and then you can start entering the properties. You can name it. There's your invert, your max rim elevation, your surcharge elevation, and your ponding. So this can take into account if the manhole surcharges or inlet, how, is that water just going to be lost? If you have ponding set at 0, then the water's just lost. If you add a ponding value that would essentially allow the inlet to surcharge, but then it would hold that water, say it's in between, it's a low spot or something, it would go back into the system when it can. You can add external flows, and you can also model treatment. So that's another piece to this software. You can add nutrient loads at certain pieces in the software. You can even model street sweeping. I mean, it's pretty robust. I can add another manhole, and then if I want to tie them together, let me move some of these around here. I just had to slide that over here so I can get all the tools. Here's a add conveyance link. So I can add a link. So that link is essentially a pipe that connected the two manholes together. If I want to look at that pipe, I can just use my pointer arrow here and set that back to there. I can double click on that pipe, and it brings up all the features of that pipe. Here's the name. It can be open channel flow. It can be a normal pipe. Here's the diameter, number of pipes. There's that 2. It can be a culvert. And it can be a direct. A direct link is essentially no pipe. It just somehow magically water gets from one manhole to the other manhole instantaneously. So probably not used too much. For force main design or anything that's pressure pipe, you have to set it to pipe and then go down to circular force main. And then once you set it to circular force main, it brings up your Hazen-Williams equations or your values, so you can enter those in. So say we had a 2-inch force main. And then essentially what this is going to do when it's open air, it's going to use Manning's. When it gets fully pressurized, it's going to flip over and start to use the Hazen-Williams equations to calculate all the flow. Let me toggle this back here for a second. So what we want to do is just model a 6-inch lateral. And we're going to say, I'm going to click OK here for now. Let's go back to this first junction. This will be essentially our source. So in this situation, we're going to have our source flow. The rim elevation is going to be 105. And our invert's going to be 100. And then our max initial water surface elevation is essentially nothing. And our surcharge elevation is essentially nothing. It's going to make it ignore that. In this situation, we want to set an external flow. So this is going to be the source from our building. And we're going to give it the dry weather sanitary flow. So this is gallons per minute coming off of that building. So let's say there's 5 gallons a minute. This pattern here, in sanitary design, there's a diurnal curve where it allows you to simulate the flows ramping up during the peak hours and then ramping back down. I'll show you that when I can flip over to this other file. And usually you'd specify that and plug that in here. I have my flow in there. So let me back up. If I do average inflow of 5 gallons per minute, that's just going to 5 gallons per minute every minute, just straight in. The time pattern curve is essentially going to take that and either multiply it by 0.3 for the 1 a.m. hour, and then the 2 a.m. hour it's going to be 0.4, so on and so forth, and then around 7, 8 o'clock it's going to be around a 2, so it's going to double that flow to 10 gallons per minute, and then sort of back it down. So that's what that time curve does, the diurnal curve. Hit close, so now I have that 5 gallons per minute. Let's see if I switch over here and show you that curve. Zoom into one of these nodes here. Go into my flow here, and you can see, so we have a time pattern established. If I click on that, and you can see the curve. So it's going to take the flow 5 gallons per minute times 0.39, so it won't be 5 gallons per minute at that time, and so on and so forth. It's going to ramp it up and down. Okay. The program comes with default curves, so if you can specify a daily, hourly, or monthly, but I recommend you definitely look into those. You have to calibrate this curve based on the system. You have to sort of look at that in more detail. Switch back here. Go back into my pipe. It's going to be a 6-inch pipe. You can tell my inverts aren't set yet, so I can simply, now that I have that upper manhole set, I can inherit that elevation from that manhole. So that's our source manhole. Imagine a building here. We have a lateral coming across, and then we're going to have another manhole. Here our invert's going to be 95, and our rim elevation is going to be 105, the same. We're not going to have any source coming in, so this is just going to be a junction 2, or manhole. Let's just call it manhole 1, I guess. So we got 5 gallons per minute. It's going to flow through this pipe into this manhole. Next piece we're going to add here is a storage node. So click that, add my storage node. Go into my storage node, and then this node essentially is where, if you're doing storm sewer design, this would be your basin or your pond, or underground storage. You can see the storage function type. You can have storage curves, so on and so forth. For this, we're just going to have, assume an 8-foot diameter wet well. Those are around 25 square feet. So you take that's essentially the square foot radius, square foot of the surface area for an 8-foot diameter wet well. Makes sense. And then it uses that square footage based on the water elevation height to figure out how much volume it's going to store. Again, initial water surface elevation, we can leave it 0, ponding 0 again, and evaporation losses 0 in this scenario. The invert, we do need to set that. We're going to set that at 90 feet. Actually, sorry, 85 feet. So this is a wet well. It's going to have quite a drop in it. And the max elevation essentially is going to be the rim. Let's set that at 105 again. And just close. Can connect a link in between those two. So now we have we're feeding that. Go back into my pipe. Get that other invert entered in there. So now you can see how you can, you sort of have to sync up your pipe inverts with your structure inverts. It doesn't do that automatically. Aaron's enter trick. Next piece, again, if you already have the nodes inverts set prior to connecting the pipe, it inherits the invert. But in this situation, we don't want to have our source pipe come in at the bottom of the wet well. Imagine a pump station, it's going to come in higher and drop. So we're going to set that a couple feet above. And set this also to a 6-inch pipe. And we should be in good shape. Here's your Manning's number. After that, we need to connect a pump. So a pump, you can see this little spacer here in between. These are all links on this side. So these are lines, the links of the lines. the structures, these are all nodes. So to connect links, I have to have a downstream structure, so I do have to place another junction here. And then I can connect this pump in between. Okay. Go into the pump. So this would, we're just going to assume there's one pump in this station. We're going to have the pump closed, so it's going to be off when it initially starts. Our operating controls, the pump is going to turn on when the manhole gets to 5 foot of water depth, and it's going to turn off when it gets down to 2 feet. There's going to be a range in there where the pump cycle is on and off. You can use your design mode, or you can enter in a pump curve. It's more practical. So you're looking for different pumps. Toggles over the pump curve option. This dialog's a little confusing because you want to start typing right away, but you actually have to hit add first. That adds a pump that you can use. The different types of pumps just has to deal with, is it volume versus flow? Is it depth versus flow? Is it head versus flow? Most pumps are head versus flow. So we're going to use a head of at 0 foot of head. We're going to pump 200 gallons per minute. Then at 50 foot ahead, we're going to pump 150 gallons per minute. Then at 75 feet ahead, we're going to pump 100 gallons per minute. Then at so on and so forth. 100. That's not good. Need more. There. And then let's go to just 200, and we're going to say 0 gallons per minute. So pump curve is a little goofy, but whatever. You would get a pump curve from you choose a pump from a manufacturer that you think is going to work best. You implement that pump curve, and then you can change it later. You can have as many pumps as you want. You can add as many pumps here. You can save them, load them, so on and so forth. I'm going to close that, and that's going to be the pump I select. From there, essentially, you're done with the pump controls. If you'd want to do a duplex station, you just add another pump. You know, if I wanted to say there was 2 pumps, we just add another one here. Essentially, you would pick the same pump curve, and then you would just have different on-off stations. You'd say, okay, from this one would turn on at 6 feet and also turn off at 2. So if the first pump can't handle it, the second pump, after it gets a foot above the turn-on stage, it kicks on the second pump, and then they both pump together. Now we want to add a couple more junctions. This is the little part that's a little goofy with the software, is that you're adding manholes here, but they're not really acting as manholes. We're going to connect lines to these. Let me back up a second here. Let me just delete those to show another feature of the software. Another option, instead of always dragging up from the top here, you can right-click on one of these and hit duplicate, and it will essentially copy that structure to the next part. Just an option. If you would have, you know, I should have had the things filled out here. Let me back up a second. What I want to do is give this some value. So say this is at elevation 100 and 105. And then I'm going to close that. And then I want to do duplicate. And then you can see by doing that, I don't have to retype in those figures.